Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the name of our inorganic compounds for class 10th. Actually from part 1 to part 9 I have explained the different name of the compounds having different cation, different anion. But after that I want to show you what is the conclusion of the part 1 to 9 where I have shown so many compounds and how the name of compounds to be done and what to be the formula of the compound. Now compound means here type of compounds you will see. Compounds mean we will see what it contains. It contains two things. One is cation, other one is anion. Cation is known as also basic radical, anion is known as acid radical. What is mean radical? Radical means an atom or group of atoms having positive or negative charge. Now what is cation? That is positive charge. Generally we observe first group elements having positive 1 plus 1 charge. Now here group 1 elements generally are metals. Hydrogen, though it is plus 1, but it is not a metal, but it forms also, it shows also different type of compounds. But important here, lithium, sodium, potassium, rubidium, they shows that plus 1 charge and exist, and those shows as basic radical. Basic radical mean that comes from base, mean that is from metal hydroxide, and that is why you can say what are the elements of first group: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Generally lithium, sodium, potassium, they shows the positive compounds, good compounds. That is why generally the question may ask of lithium, sodium, potassium and rubidium also. But after that also we can see the ammonium plus 1, this is NH4 plus mean plus 1, that it also shows that is as a monovalent cation, and that means plus 1 charge. If we will write plus, only plus, that means it is plus 1. Now these are called as monovalent cation. Now come to divalent cation. Di means 2, plus 2 charge. Generally who shows plus 2 charge? Group 2 elements, they show the positive charge. What are the group 2 elements? Magnesium, calcium, strontium, barium, radium. Generally these are very active and those shows different type of compounds. Generally the name can be asked. We can see the different compounds regarding magnesium, calcium, strontium and barium. Magnesium, that shows positive 2. Similarly, here all are showing plus 2 charge. That is why they are called divalent cation. Now, second group elements, they are having plus 2 charge. Okay, except that here some exception are there. Cu, Zn, Fe, these elements, copper, zinc, iron, lead, nickel, mangan, these elements are, that mean here they are known as transition elements. So these transition elements, we should remember now, this transition element shows plus 2 charge. When come to copper, copper shows plus 1 charge, plus 2 charge. Plus 1 is called cuprous, plus 2 is called cupric. When come to zinc, zinc only plus 2 charge. Iron shows plus 2 charge and plus 3 charge. Plus 2 is called ferrous, plus 3 is called ferric. Pb mean lead. Plumbum, in chemistry it is plumbum and it is only known as lead. Lead is famous. Pb plus 2. Nickel, Ni plus 2. That is nickel plus 2. Manganese plus 2. Now you can see these are the exceptions. So many exception cases are there. There is no limit at all. That means here this is only the rule and regulation. Only will follow for this. You can see so many elements are, so many metals are there where it shows positive plus 2 charge, and so these are known as plus 2 charge having, they are called divalent cation. Now plus 3 charge cation, plus 3 charge, here you should remember some fews are there, but we should remember what are the metals. Fe plus 3 ferric, Al plus 3 aluminium. Then come to Bi. Bi mean bismuth plus 3. As plus 3. Remember here Bi plus 3 also shows Bi plus 5 and As plus 3 arsenic also shows plus 5. That means bismuth shows 2 charge. One is plus 3, other one is plus 5. Plus 5 you can do yourself, so few compounds are there. Similar arsenic plus 3 and plus 5, that is why here you can also form different compound, arsenic pentachloride like this, bismuth pentachloride like this. Now plus 4 charge also there are also few, Pb4, Pb plus 4, you see Pb plus 2, lead plus 2 there, 2 plus 2 charge, divalent charge is there, divalent cation is there, and now it is tetravalent cation, and here also they shows few compounds. You can try yourself, just like lead PbCl4 where the charge is plus 4. Stannic chloride, this is called stannic chloride, this is called plumbic chloride. Plumbus plus 2, plumbic plus 4, but plus 2 is very famous, and plus 4 plus 4 for lead it is plumbic, for tin it is called stannic. That means Sn means tin, stannum, in chemistry it is stannum, stannum changes to stannous. When it is called stannous it is plus 2, when it is stannic plus 4. So you can try yourself, so few compounds can be possible. So I hope it is clear. Basic word comes from base, acid comes from acid, that is why this is basic radical. Radical means one atom or and many group of atoms having charge plus or minus. And now cation is positive charge, and that generally group 1 elements regarded as plus 1 charge and group 2 elements regarded as plus 2 charge. Exception case ammonium where plus 1, and here exception case copper, zinc, ferrous, lead, nickel, manganese they shows plus 2 charge, and plus 3 charge, that is trivalent cation, and here Fe plus 3, Al plus 3, Bi plus 3, As plus 3. It also shows that lead and tin also shows plus 4. Similarly, bismuth and arsenic also shows plus 5. Now we will say what are the different anions, how can you remember the anions, then how always you can form easily the compounds between that means with our cation and anion. How can you name it easily? That already I have cleared in from part 1 to part 9. Only the conclusion here I want to draw it. So we will proceed to anion now. Then we will go to different form of anions. What are the type of anions? Anions means negative charge. Anions are also called acidical. Why it is acidical? Because it comes from acid part. You know compound consists of one part is basic radical, that is positive cation, and other one is negative, that is anion. That here anions so many types. One is monovalent, divalent, or third one is trivalent. Mono mean 1 minus charge, divalent mean minus 2 charge, and trivalent mean minus 3 charge. Now see monovalent anions, HCO3 minus 1, that is hydrogen carbonate. Before that it is also known as bicarbonate, but nowadays it is called hydrogen carbonate. HSO4 minus 1, that is called hydrogen sulfate, or you can say bisulfate, but now it is known as hydrogen sulfate. HSO3 minus 1, hydrogen sulfite, and OH minus 1, hydroxide, Cl minus 1, chloride, Br minus 1, bromide, I minus 1, iodide, and fluoride, F minus 1, fluoride. Similarly, chlorate, ClO3 minus 1, chlorate, ClO4 minus 1, perchlorate, MnO4 minus 1, permanganate, and nitrate, nitrate, ATE, both are minus 1. So when you read, you should remember what are the monovalent anions. Monovalent anion, here you will remember here all the monovalent anion. Then come to divalent anion. Divalent means minus 2 charge. Carbonate, CO3 minus 2, sulfate, SO4 minus 1, sulfite, ITE, SO3 minus 2, it is minus 2, this minus 2, sulfide, S minus 2, O minus 2, oxide, zincate, ZnO2 minus 2, chromate CrO4 minus 2, Cr2O7 dichromate, MnO4 minus 2 manganate. Now these are the anions where the charge is 2 minus 2, and you should remember these are called acid radical and also anions having divalent charge. Trivalent anion P minus 3 phosphide, N minus 3 nitride, see the spelling nitride IDE. Then here PO3 minus 3 phosphide ITE, PO4 minus 3 phosphate ATE, ASO4 minus 3 arsenate. These are the most examples. You can see also other monovalent and divalent, trivalent ions if possible, and also try to make the compounds how the charges will join and to form the compounds. And already I have explained in from part 1 to part 9. Now here I will show only one or two examples from each case. Monovalent anion, monovalent cation, like this I will show you. And when you read, please start from part 1 to part 9, then after that you see part 10, because part 10 is the conclusion of part 1 to part 9. So now we will proceed how the compounds are formed from different anion and different cation. Now we will proceed here. So you will see the different examples. Now you can observe here the type of compounds. What are the type of compound? First one, see, monovalent cation and monovalent anion. Both are charge 1. One cation is plus 1, anion is minus 1. Similarly, your example you can see sodium plus 1, chloride minus 1. So the formula is NaCl. And other examples I already told in from part 1 to part 9. And monovalent cation and divalent anion. Monovalent potassium, see this is the potassium, and here sulfate, it gives K plus 1 and SO4 minus 2, so K2SO4. And see monovalent cation and trivalent anion. Monovalent, you take lithium, let's take lithium, and lithium plus 1, PO4 minus 3, so formula is Li3PO4. Divalent cation and monovalent anion. Divalent cation means here the cation just should be positive too, and up to here 3 examples I have given: monovalent cation, monovalent anion, monovalent cation and divalent anion. Similarly, monovalent cation and trivalent anion completed. This is one part. Second part you can observe divalent cation and monovalent anion, means the cation should be plus 2 and anion should be minus 1. Now you see magnesium hydroxide, magnesium plus 2 and OH minus 1. Why magnesium plus 2? Why lithium plus 1? I already told in part from 1 to 9, and now here you can see magnesium 2 will come to here and 1 come to here. What is the formula? Magnesium hydroxide MgOH whole 2. Again see monovalent cation, monovalent anion, monovalent cation and divalent anion, and here monovalent cation, trivalent anion. Finish up to your monovalent cation. Then we will start here divalent cation and monovalent anion, and after that we will see divalent cation and divalent anion, then divalent cation and trivalent anion. That is the part 2. This is part 1 from monovalent cation, and this is part 2 where we will see divalent cation. So already I have started here, and you will see other examples of trivalent anion and divalent anion. Now see other examples of different type of compounds. I already said divalent cation and monovalent anion example I have completed. Now see calcium carbonate. Calcium, see divalent cation, calcium is divalent and carbon is divalent. So divalent cation, divalent anion, what happened? 2 cancel, so the answer is CaCO3. Again see divalent cation, divalent anion, cancel, so CaCO3. Now divalent cation and trivalent anion. Now divalent cation means just like here Ba plus 2. nitride, that is trivalent anion, N minus 3. What is the answer? Ba3 and 2 here, nothing cancel. 3 comes to here and 3 comes to here and 2 comes to here, and this is the answer. Then come to trivalent cation and monovalent. This is part 3. Trivalent cation and monovalent anion. See, trivalent cation, you take example aluminium plus 3, nitrate NO3 minus 1. So 3 come to here, and that is why AlNO3 whole 3. Trivalent cation and divalent anion. Trivalent cation, you take ferric, one example, sulfide, that is divalent anion. So 3 comes to here and 2 comes to here. So the formula is Fe2S3. Now next one, trivalent cation and trivalent anion. That means aluminium, example aluminium phosphate, aluminium where it shows plus 3 valency and PO4 having minus 3. So that is why AlPO4, because 3 cancel each other. These are the types. Again see, there are 3 parts. Part 1 you will see monovalent cation. Part 2 you will see divalent cation. Part 3 you will see trivalent cation. So monovalent cation with monovalent anion, this is 1. Monovalent cation with divalent anion, this is 2. Monovalent cation and trivalent anion, this is 3. So in part 1 3 types are there. Now come to part 2. Part 2 I told divalent cation with monovalent anion, divalent cation with divalent anion. Similarly, divalent cation with trivalent anion. This is part 2. Part 3 will see trivalent cation, monovalent anion 1, trivalent cation and divalent anion part, this is 2, and trivalent cation and trivalent anion, this is 3 types. So what happened here, each part consists of 3 different type of compounds you can form. You can write the formula correctly. Only you should remember what are the anions, what are the cations, and after that how the cross multiplication takes place in for the different anion. Now example, you can see this example, barium, that is your cation plus 2 divalent cation, N minus 3, that is trivalent anion. So the formula Ba3 and 2. I hope it is clear. It is one of the it is one of the important form and how to write the formula of different compounds. Please, it is my request, please read from part 1 to part 9, and after that go to part 10, where you will clear all the difficulties with you. And I hope it is clear to you. You can write any formula of the compound if you know the cation, anion, all the things what I told. If more things if you want, then you can refer any possible anions are there. You try to write. So many anions are there, but up to here it is sufficient. And if you go to high class, you can see so many different anions are there. You can try to write the different form of the compounds. And I hope you will subscribe my channel BL Das, short and sweet in chemistry, and also please share and like my channel. And thanks for watching my video. The topic is name of the compound. This is the last part of the name of the compounds. Then I will proceed to different compounds are there. You should know, that is sulfur dioxide SO2, just like nitric acid HNO3. Like this, some important compounds used in daily life, either in reading or in practical chemistry lab, it is required. That is why in part 11 I will explain different form of compound that we should remember for our purpose in lab or in our reading. So thanks again to all.